Good morning. Like we said, I'm the observing program leader down at the Weather Service office in Greenville, Spartanburg. But at least for the time being, I'm also managing the hydrology program at the office due to the retirement of our long-term service hydrologist, Patricia Tanner, back in May. And she had been doing much of the work over the past 20 years with respect to hydrology and gauge operation and coordinating with all our users across the Western Carolinas. My splash screen here, or my title screen, is the photograph of the USGS gauge down at the Pearson Street Bridge, and that is the official forecast point for the French Broad at Asheville. I'm going to talk a little bit about kind of what we do down at the Weather Service, and the latter half of the presentation will be kind of a quicker review of the effects of the tropical remnants 10 years ago. This is the mission statement of the Weather Service, and our primary mission is to provide weather and flood warnings for hazardous weather for the protection of life and property. And our area of responsibility includes 46 counties in the Western Carolinas and extreme Northeast Georgia. Our office is here at the Greenville-Spartanburg Airport. 13 of the North Carolina mountain counties are which we have responsibility over, and I'd like to point out that neighboring offices in Morristown, Tennessee and Blacksburg, Virginia have similar responsibilities for the balance of the North Carolina mountains and adjacent areas of Tennessee as well. The hydrologic service area for the Greenville-Spartanburg Weather Service office is interesting because the divide, which is on the southeastern kind of fringe of the North Carolina mountains, roughly bisects our forecast area. And the major basins across the North Carolina mountains, or on the west side of the divide, flow to the northwest, eventually working through the Tennessee, Ohio, and Mississippi valleys. And our Piedmont basins flow southeast into the Atlantic. So it's very important to which side of the divide excessive rainfall falls for us to determine which basin will have the greatest rises. In addition to the 122 local warning and forecast offices across the United States, like the one at Greenville-Spartanburg, there are, is that it? That's that? Sorry, that was quicker than I thought. There are 13 river forecast centers which provide hydrologic support to our warning operations as far as hydrology goes. On either side of the divide which I just mentioned, we have two servicing river forecast centers for the basins which drain into the Atlantic. The Southeast River Forecast Center in Peachtree City, Georgia, provides main stem forecasts for these basins, and hydraulic support and forecasts for the mountain basins are provided by the Lower Mississippi River Forecast Center, and that's in Slidell, Louisiana. Just a few of the things that the river forecast centers assist the local WFO in. They are the providers of what we call flash flood guidance on a fairly small scale. We often, in one of the tools we use in our office, we can scale them as low as very small subbasins, and the idea behind flash flood guidance is to provide assistance in monitoring excessive rainfall and the issuance of flash flood warnings. Their primary job is for the issuance of river and stage forecasts and flood forecasts for the main stem rivers, and they also provide QPE and QPF. The QP is quantitative precipitation, the E is estimates, what has fallen, and the F is forecast. because a big component of their river forecast is how much rainfall is expected. Here is a screenshot of an application that we use at the Weather Office. It is the HydroView application. I have it zoomed in to the county warning and forecast area of the Greenville-Spartanburg office, outlined in red. And here's the divide, which I just mentioned. The Lower Mississippi River Forecast Center provides daily river forecasts for 9 locations across the North Carolina mountains within the Greenville-Spartanburg HSA. 6 of those are actually along the French Broad Basin, from Blantyre all the way downstream to Hot Springs before it exits into Tennessee. There's a couple of other forecast locations along the Pigeon River and parts of the upper Little Tennessee. That's the Tuckasegee and the Birdtown River coming out of the Smokies. Over the past 20 years, the Greenville-Spartanburg Weather Office has worked with local users, emergency management, to establish various impacts so that specific river forecasts can be related to what it actually would get affected during various flood levels. I would also like to say that in addition to those forecast points, there's a smattering of data, or what we call support points or stream points, that flow into our major tributaries. A lot of these, the majority of which are installed and maintained by the USGS and the North Carolina iFlows. And I just put some of the examples of some of the smaller basins which feed into our main stems, which we have stream gauge information for. In addition to the Doppler radar estimates, it's important to have ground truth as far as how much rain has fallen. This is kind of a snapshot of virtually every gauge in our database. It's a mix of official cooperative weather observers, several hundred automated gauges from various partners of the Weather Service, which once again includes the USGS, includes the North Carolina iFlows. And we have another network which started in North Carolina about 2007, and that is the COCORAS. I kind of consider that our officially sanctioned volunteer rainfall observer program. And I would like to give props to them. This is the COCORAS webpage, and we are always looking for weather observers. They report once a day with an official looking 4-inch plastic rain gauge. And there's quite a bit of COCORAS observers across the North Carolina mountains, and active observers in Buncombe County are probably greater than 40. So, and it's kind of clustered around population too, which is, I guess that makes sense. The iFlows program is one I want to talk about next. We go. This is once again, our HydroView application filtered for the iFlows rain and stream gauges across the North Carolina mountains and foothills. You know, it is a mix of state, county, and locally maintained rain and stream gauge networks. And here's a couple of snapshots of what the typical iFlows gauge looks like. This is an iFlows rain gauge way out in the Deep Creek area near Bryson City. And this is another different style rain gauge. The Stillingwell is the type of the long pipe here. And the majority, if not all, of the iFlows gauges are telemetered via radio. You can kind of see the radio antenna to various repeaters and then base stations across the mountains. I didn't put a snapshot of a stream gauge, but essentially the data logger and communications gear it looks very similar, minus the rain gauge right here, which is the tipping bucket, and is typically located on a bridge or a bank. And most of the iFlows maintained stream gauges are of the pressure transducer type to measure stream gauge levels. For the public to access data from the iFlows network, there is the AFWS page, Automated Flood Warning Systems page, and as you can see, this mirrors the iFlows plot, and anybody who accesses this web page can click on a dot and see rainfall intervals of the appropriate time period. And my example gauge was a rain gauge kind of just upstream of here along the Swannanoa near Warren Wilson College. One of the most important things that we use automated rain gauge data for, or near real-time data, is for the calibration of our rainfall radar estimates. Here's a screenshot of precipitation estimates from our WSR 88D, and especially in the North Carolina mountains where we have what we call beam blockages. The radar is at the GSP airport elevation, approximately 1,000 feet. So the further we try to estimate data away from the Blue Ridge, many times that the precipitation amounts are underestimated, and it's very important to have ground truth to kind of recalibrate and set biases for what the radar is depicted. We do have map overlays on the background where all of our gauges are for a quick reference to the forecaster to check the rainfall with reality. iFlow's stream gauges and USGS stream gauge information is publicly available in one spot on this AHAPS page. This is, I forget what the Automatic Hydrologic Prediction Services. And just want to point out, anybody who uses this web page, the circles are where the forecasts are provided, and the squares are just data points where you get just observed data. When you click on one of those circles, for example, you get a hydrograph. It is a trace of the past river levels and the forecast. This is the Swannanoa gauge right down here in Biltmore. One more thing I want to point out about the AHAPS page is the ability to view inundation mapping for select gauges, and this is from the Biltmore gauge as well. Here's the gauge location along the Swannanoa, and the best thing about this is you can mouse over various levels of the river along this reach, and you can actually see what the LIDAR data, which was used to map this, what would inundate and to what depth. And the second half of my presentation, just want to talk briefly about show some rainfall maps and the effects on the gauges that this near record or record rainfall showed. You saw this slide on Doug's presentation, the track of Hurricane Francis, and it was about the 8th to the 9th of September where the tropical remnants, probably still a tropical depression at this point, passed just west of the North Carolina mountains, and copious amounts of tropical and upslope enhanced rainfall had this stripe of excessive rainfall, 12 plus inches in spots. About 9 days later, visited by Ivan and his remnants, a very similar track just to the west of the North Carolina mountains. Once again, localized upslope enhanced rainfall, pockets of 10 plus inches across the mountains and adjacent foothills. One more thing I want to mention about the Ivan event is we had kind of one of our benchmark debris flows, and once again there'll be a later presentation on this. This is a screenshot from the Peaks Creek debris flow, which occurred during the evening hours of September 16th. There were several homes destroyed, injuries and fatalities with that. This occurred right here in southeast Macon County. By this point in the month, between the two rainfall events, there was probably about 18 inches of rain which had fallen in southeastern Macon County. I do want to show you the Jeanne track, which was interesting because unlike the previous two remnants, that actually passed over the central Carolinas across the Carolina and Georgia Piedmont during the latter half of the month. And you can see here the more uniform distribution of locally heavy rainfall. It was not just localized across the upslope areas, but it was more uniform from the Blue Ridge to the Piedmont, kind of along the track of the tropical remnants, which I thought was a little different than the previous two tracks. I'd like to conclude with just a summary of what exactly the gauges along the main stem rivers reached during that period. This is a zoomed-in version of the one of the first maps I showed you with our forecast points, and this is the French Broad Valley, Blantyre down to Marshall. And during Francis, the major flooding obviously occurred along the Swannanoa and the French Broad River. The forecast points at Asheville, at Biltmore, and Blantyre during the 8th and 9th of September all experienced their highest crests since 1916. There was also flooding along the Pigeon River, where a record crest was set on September 8th. And during Ivan, there actually was a second, albeit slightly less crest, but it still was above what we'd consider major flood stage along the Swannanoa at Biltmore. Since 2004, giving props again to the local efforts in expanding the I-Flows network, new stream gauges were installed along the Swannanoa and various tributaries. Also, the main tributaries which flow into the French Broad and flow through Greater Hendersonville were added as well. So this gives us a better representation of actually the crests moving through the river systems than before. In addition to stream gauge expansion, the city of Asheville added a slew of rain gauges across the Swannanoa Valley, and once again, more representative rainfall coverage was accomplished by the addition of these rain gauges across the Swannanoa Valley. And one of the more important things as well, the North Fork Reservoir advises the Weather Service when they give us information about gate openings and how much CFS is being added to the Swannanoa, so we can pass that information along to the river forecast centers to kind of tweak their forecasts along the Swannanoa River at Biltmore. So I guess so. Is that enough time or?